So in this section, I will decompose into a partial fraction with repeating quadratic factor. So example 4, we have a repeating quadratic factor. We got to decompose into partial fraction. So we have x cubed minus 4x squared plus 9x minus 5 all over parentheses x squared minus 2x plus 3 squared. And we have to decompose it. So what we have is a repeating quadratic factor. So this is a repeating quadratic factor. So you're going to break it up to this. So this right here, this bottom, it could be written as x squared minus 2x plus 3 twice, right? So that's why I put it here once and then the twice here. So what do we put on top here? Since the degree has to be bigger on the bottom than the top, it's going to be ax plus b, right? Because this degree has to be uh, smaller than the bottom, and then you need a constant. And then the next one would be, because this is, don't worry about this power 2, it's the inside parentheses powers we care about, so this 2. So this one has to be so the top has to be smaller than the bottom. So it's going to be, instead of we'll have to use our different letters, so maybe we can use C, X, and then you need the constant, right? So we need to find our A value, we need to find our B value, we need to find our C value, and we need our D value. So how will we do this? It's a little bit different. We're not going to plug in a value. What we're going to do is, I'll show you. But what's the first thing we have to do is get rid of the fraction by multiplying all three sides by the LCD. So what do you think the LCD is? Yes, you're correct. The LCD is basically the bottom, x squared minus 2x plus 3 squared. Okay, so you're going to multiply all three sides by that. And then on the left side, the bottom cancels, so you're just left with x cubed on the right. The bottom can actually, on this, when you multiply this out, it doesn't complete, you're still left with the power of 1. So it's going to be ax plus b times, you're still left with this because 2 parentheses 1, it just cancels in, you're left with power 1. Plus, and then on the right, what do you see that cancels everything? So you're just left with cx plus d. Okay, so how we're going to find this is, well, first I'm going to kind of FOIL it out and then collect like terms, and then I'm going to line it up with the left side. So ax times x squared is ax cubed. Ax times negative 2x is negative 2ax. Ax times 3 is 3ax. B times x, that's bx squared. B times negative 2x, that's negative 2bx. B times 3 is 3b. And then over here, you just bring it down. And then on the left, just bring it down. Okay. Then what I'm going to do on the right side, I'm going to collect like terms. So let's start with the highest power, x cubed. Do you see anywhere else with an x cubed? No. So just bring it down. Let's start, the next one would be the power of 2. This right here should be a power 2. Okay, so you can circle a box or anything with anything with a power 2. So I have a power 2 here, a power 2 here, and that's it. Even though you can't combine them, right? This is the reason why you can't combine them, because this has an A and this has a B, but just, kind of line them up. And then you have the power x1. So I'm going to circle. I have a 3x here, a minus 2bx there, and a plus cx. So I can't combine them, but I can just kind of line them up. So it'd be plus 3ax minus 2bx plus cx. Okay, and then what else am I left with? I'm left with the the 3b and the d, right? The 3b and the d, so 3b plus d. Okay, then what I'm going to do, so ax cubed just stays the same. And then even though this has an x squared, what I could do is factor out an x squared, right? I could factor out an x squared because they both have an x squared. That's what I want. I'm going to factor out an x squared, and I get negative 2. Then you're left with negative 2a plus b, right? And then the same thing with these two terms. They both have an x, so I can factor out 1x. Oops, I forgot the c. Oops, that. Good. And then you're left with the 3b, 3b plus d. Okay, and then what you're going to do next is kind of like line them up. So ax cubed kind of goes with x cubed, right? So you can say Yeah, you can set it up as x cubed equals to ax cubed. So what I'm doing is basically making equations. And then negative 4x squared is kind of lines up with this because they both have an x squared. So you could say negative 4x squared equals to this whole thing. And then the 9x kind of lines up with this whole thing. And then the negative 5 is related to the 3b plus d. Okay, so let's look at the first equation, x cubed equals ax cubed. Uh, what can I say? Well, if I divide each term by x cubed, the x cubes cancels. Well, this cancels, and actually this really just becomes 1. So you have 1 equals a. So your a value is 1. What about here? What I'll do is get rid of the x squared by dividing both sides by x squared. So you're left with negative 4 equals to negative 2a plus b. I'm going to just leave it like that for right now. I'm going to probably have to do substitution. And then over here, I'm going to get rid of the x by dividing both sides by x. So it's 9 equals to 3a minus 2b plus c. And this one I can't really do much. I'm just going to rewrite it. Okay, so now what I'm going to do is kind of use what I have. So I know I said that a equals 1, so maybe I can plug in a back into this equation and then I can solve for b, right? So it's negative 4 equals negative 2 and then replace a with 1 plus b. Negative 2 times 1 is negative 2. Solve for b, add 2, add 2. Negative 4 plus 2 is negative 2. And then I could plug in my a and my b value into this equation to find my c value, right? So it's 9 equals 3 times a is 1 minus 2 times b, which is negative 2 plus c. 3 times 1 is 3. Negative 2 times negative 2 is 4 plus c. 4 plus 3 is 5, 6, 7 plus c. Solve for c, so I could just subtract 7 from both sides. I get c equals to 7, 8, 9. That's 2. Okay. And then lastly, I could find my d because I have my b value, right? So this would be negative 5 equals 3 times b, which we said was negative 2 plus d. 3 times negative 2 is negative 6 plus d. Add 6 to both sides. 6 minus 5 is 1 equals to d. Okay, so I have my d value. So uh, it's going to be, so your final answer will be Okay, so your final answer is we said our A value is 1, my B value is -2, and my C value is 2, and my D value is 1. So your final answer would be expressed as x, because A is 1, and my B value is -2, so it's x minus 2 over x squared minus 2x plus 3 plus C value is 2, so it's 2x plus my D value is 1 all over x squared minus 2x plus 3 squared. So this decomposes to this, and you can easily integrate this by using U substitution. Okay, so yeah, this was partial decomposition with a repeating quadratic factor. I'm going to stop here.